Okay, we're going to look at an integral in section 5.2 that we need this generalized power rule for. So I think the integral kind of speaks for itself. It's definitely a little bit more complicated than the ones we saw in the last section. It's the integral of the square root of 4x squared minus 5 times 8x with respect to x. So this is the function we're integrating, this 4x squared minus 5 times 8x. It's a pretty complicated function, and it's certainly not something we can use any of the 5.1 rules on. You know, it's not just a couple powers of x added together or a constant times a power of x. It's just more complicated than that. So often when we have a more complicated integral like this, we can use the generalized power rule, perhaps along with some of our other rules, to integrate. And what the generalized power rule is, it's just this rule in the box. And if you look at these last two parts, by the way, I think in the notes I have put quotes around this, because this is the way we kind of think of it. The way we think of this rule is as follows. Suppose we have some integral with respect to x, okay, and it's a tough integral. Well, maybe we can make a substitution and replace all that stuff with x with a different variable. Okay? And the idea is if we make a certain substitution, we might get a new integral with respect to a new variable, which we call u. That's a lot easier to do. Okay? So the generalized power rule just tells us if you have some expression to a power times the derivative of that expression, okay, and you're integrating that with respect to x, what you're really doing is you're integrating this new expression u to a power with respect to u. Okay, and of course to do that we just use the regular power rule. You know, we take 1 over the old power plus 1 times u to the old power plus 1 plus a constant. And by the way, just to kind of tack this in here, this rule, just like the power rule, works as long as the power is at -1. That's the one requirement. Okay, so maybe the one thing that's new is this thing called du. What we do here is make a substitution. I'll go through and look at this one. The integral we have, okay, is the square root of 4x squared minus 5 times 8x. So what we try to do is we try to replace something with u. So we usually call the most complicated expression that's being raised to a power or taken inside of a root, we call that u. So I'm going to let this be u. I'm going to let u be 4x squared minus 5. Okay. So what we have here really in our integral, if you look at it, it's u to the power 1/2. Right? If I just call this 4x squared minus 5u, I can write that as u to the power 1/2. Okay, but I also have 8x and I also have dx. Okay. So I've got my u to a power. Okay. Well, once I choose u, I have to see what the derivative of u is. So what's the derivative of this with respect to x? Well, the derivative of 4x squared is 8x. The derivative of -5 is 0. Okay? So look at that. I have u to the power 1/2 times the derivative of u. Okay? So that's my du dx. Okay? Times, of course, dx, the differential. Okay? Now the book, and in fact the only thing that changes in these first two lines of the generalized power rule is that we can call the derivative of u with respect to x times dx. We can just call this du if we want. Okay, just another name for those two things. Okay, but what we see here is really what we're doing is we're just integrating u to the power 1/2 with respect to u. That's what this rule is telling us. So what we've supplied in this problem is a substitution. We took some complicated part of our integral and replaced it with u, okay, which gives us this much simpler looking integral. Okay, we're just taking the integral of u to the 1/2 du, and you could say it's the generalized power rule, but it's really just the power rule. How do you integrate u to a power du? Well, you take 1 over the old power plus 1, so 1 over 1/2 plus 1, that's 3/2. Times u to the power 1/2 plus 1, that's 3/2, okay, plus c. Okay, so this is, let's see, 1 over 3/2, that's 2/3, u to the 3/2 plus c. Okay. So finally, we've integrated, but we do have to convert back to x. You see this substitution we made, this substitution we made was only so we could get the rule to work. The problem itself never mentioned u. This whole thing here is the problem. So u is something we invented ourselves to make an opportunity to use a new rule. So I have to remember what u was. U was 4x squared minus 5. So my final answer is 2/3 times 4x squared minus 5 to the power 3/2 plus c. Okay. So that's the indefinite integral of what we started with. Now I do have to say in this one that this generalized power rule works on a lot of complicated integrals, but you do have to have kind of the right thing there. I mean, if you notice, we had the square root of something called u, and then the next expression was exactly the derivative of u, which has to be there, right? We need u to a power times the derivative of whatever we decided u was going to be, times dx. Okay, and we had exactly that. Okay, u to the power 1/2 times exactly the derivative of u, that was the 8x, times dx. So we were able to make this substitution work pretty easily. Now, if it doesn't work right off the bat, there are some things we can do, but again, you'll see in the future example, the generalized power rule doesn't always work. Okay, but it does help in quite a few examples like this one.